Cruising along into number 4. Here's some problems where we're going to solve by square rooting. You can solve by square rooting if you can set the problem up so that you have something squared equals number. Let me say that again. You can use square roots anytime you can make the equation be something squared equals number. So take a look at A. Can't we make this x squared equals number just by adding a 48 to both sides? We're left with x squared equals 48. Okay, that's a good start. Next thing is you take the square root of both sides. When we take the square root, something kind of interesting happens. One, the square root and the square, they cancel, so we get x on this side. But on the other side, we get both a positive and a negative answer. And the reason is that positive roots of 48 and negative roots of 48 will both make this equation true. Imagine putting, say, a negative roots of 48 in here. When you do negative roots of 48 times negative roots of 48, you get a 48. Subtract, and you get 0. So they both work. Now, I am going to ask you to take these bad boys and simplify. So simplify means from our list of perfect squares, 1, 4, 9, 16, 25, 36, 49, we need to grab the biggest number that we can pull out of 48. So 49 is not a factor of 48, and neither is 36, and neither is 25. But 16 is. Specifically, 16 times 3 is equal to 48. So you need to take this and rewrite it as roots of 16 times roots of 3. And then we say the square root of 16 is 4. So x will be equal to plus or minus 4 roots of 3. And that's our final answer. The goal, by the way, is to make the number that's inside the radical as tiny as possible. Let's move along. Next one. The nice thing on the next one is that it's already set up for us. See that we already have something squared equals number. So we could begin this problem by taking the square root of both sides. On this side, we're going to get 2k minus 5. On the other side, the square root of 36 is 6. There's a positive and a negative solution to that. So we're now going to solve two separate equations. 2k minus 5 is negative 6. 2k minus 5 is 6. This one, add 5 to both sides, you'll get negative 1. So k is equal to negative 1/2. I want to emphasize again, with all of these, you can always take that number, plug it in up here, test, and make sure that it works. Same thing with the other one. Add 5 to both sides. 2k is equal to 11. Divide by 2, you get that k is 11/2. So there are our two solutions. Just like on the last problem, we got two solutions. Moving along to C. Okay, on C, I was a nice guy once again. I gave you something squared equals number. So we can begin by square rooting both sides. On this side, we get a minus 1. On the other side, we get plus or minus the square root of 12. But let's remember that the square root of 12 can be rewritten as the roots of 4 times the roots of 3, which would be 2 roots of 3. So that's the form we want to use. The number inside the radical is smaller. Okay, so what do we do from there? Well, I need to add the 1 to both sides. Technically, what you're doing is you're solving this equation. A minus 1 equals negative 2 roots of 3. And you're solving this equation. A minus 1 is equal to 2 roots of 3. When you add 1 to both sides, The question is, can you add this 1 to part of this? And the answer is no. Here's why. Think about what that 2, oh, that really does not look like a 2. Let's see if we can jazz that up a little bit. Now we're talking. Oh, that's even worse. Hang on. There's a 2. So 2 times roots of 3. Since this is multiplied and this is added by our order of operations, you have to multiply before you add. Since I don't know what 2 roots of 3 is, and I'm just going to leave it that way, it means that our best possible answer looks like this. 1 minus 2 roots of 3. On the other side, we get a is equal to 1 plus 2 roots of 3. If you're feeling lazy, you could simply write your answer this way. You could say a is equal to 1 plus or minus 2 roots of 3. And that is just as good. Moving on to the last problem. Here I've got a squared plus a squared equals 1. So this would be a situation where you're going to have to do a little simplifying first, starting with this. What is a squared plus a squared? Well, that would be 2a squareds is 1. So a squared is equal to 1 half. I divided both sides by 2. Take the square root of both sides. You would get that a is equal to plus or minus the square root of a half, which is a perfectly good number. I'm happy with that. That's a good answer. However, you should be aware that we could clean it up, or we could at least rationalize it by multiplying by roots of 2 and roots of 2, which means that a perhaps even better answer would be roots of 1 times roots of 2 is roots of 2. Roots of 2 times roots of 2 is 2. And there we have it. I'll see you in video number 5.